Today I want to show a very brief intro onto some FEA stuff or the SolidWorks simulation. So, excuse me. So if it doesn't show on your tab here, like up here or not down here, right click on anywhere up here, and I know you can't see this, but then you're going to come down to toolbars and then go to simulation, and then it should, or add-ins or something like that, and it should pop up. Or make sure you have SolidWorks add-ins tab and then SolidWorks simulation. So it's going to take a little while to get into your simulation tab, so just give it a second, for me anyway. Yeah, it's kind of glitching out. Forgot I muted my mic there real quick. Man, my computer's being weird. Okay, so first thing you need to do, new study. For just basic stuff, just keep it as a static. There's tons of different things you can do, but I'm just going to name this tutorial and then hit OK. So there, oh man, I wish you guys could see this. So when you hit apply material, a pop-up screen comes in here, and there are tons and tons of already loaded in SolidWorks materials, but they're not always exactly what you might be using in your application. So you can make your own. There's just play around with the window here, and you'll you'll see what I mean. But see how this changed the color? So that's just the SolidWorks default for that material that I picked, which is this AISI 316 annealed stainless. So first thing you want to do, fixtures. I don't ever use the advisor, but one thing you need to remember, so fixed geometry, that means that it will not move in any direction. So you see these arrows? That's saying up and down and left and right. It does not move. There's roller slider, which means it can move left and right, but not up and down. And then this isn't a fixed hinge, so it's not going to show you. But one thing you need to keep in mind is when you do a fixed geometry, it does not allow any movement. So if your part actually does allow a little bit of movement, because say it's like welded to something or bolted to something, you're going to have higher stresses than you intend to. So, which is good, because then you'll have a higher safety factor than what you are assuming. But here's what we're going to do. So yeah, we're going to keep it simple. So load advisor. So I'm going to read them off since you can't see them. There's force, torque, pressure, gravity, centrifugal, bearing load, remote load, distributed mass, temperature, flow effects, thermal effects, prescribed displacement. Well, we're going to do a good rule of thumb is to just always put gravity on the, and it'll see how it popped up as the entire body. The whole body is under gravity. So unless you're working on stuff in the moon or on the moon, you don't need to worry about it. But it's a good rule of thumb to just always do gravity in the direction of that your part is going to have gravity acted on it. And then I'm going to add, you can do a pressure here, kind of wherever you want, depending on how your part is being loaded. But let's say this is a step, right? For like a little step up, for like you bolt it to like the side of your tractor or like the side of whatever. And that's the step. So since we're American, or I'm American anyway, we're going to throw PSI on there, and then pound per square inch. I can't remember how many. square inches this is, but I'm going to say it's like 3 square inches. So to assume how many pounds there are on 3 square inches, I'm like 230 pounds. You just do 230 divided by 3, and then that's what you get, 76 psi per inch, right? And then if for whatever reason it's loaded in the reverse direction, you can do that. And then if it's not uniform, you can say whatever distance from the axis, whatever. I don't do a lot of that. And then you hit OK, right? So if you're bolting stuff or whatever, you can run the connection advisor, but you don't need to. So then you just hit run this study, and a little pop-up will come up and just show that it's loading. Excuse me. And so now this is your von Mises, and the way this works is, let me change this into real units. I know people might get irritated for me saying that, but it is what it is. I like to come down here and do floating, because then it gives you the whole number, and then you just hit OK, and then it's in PSI. So two things to know. Corners, sharp corners are force concentrations. So you can get rid of that with a fillet, or like a series of chamfers if you want. But pretty much, so this tells you the yield strength, right? So this is set up to where red is just the highest. So straight out the box, a good safety factor is 3. So 20,000 divided by 6 is like more than 3, so you're good. And so if you wanted to fix that, you could, but I would say this little step is a solid design. If anything, there's going to be some wear and tear there, but this thing is pretty good. And then you can have your deformed result too, right? So it looks like it moved a whole bunch, but when you come in here, oh, real quick, excuse me. Von Mises is, look up Rosette strain gauge, and it's essentially all 3 axes on a plane, and then it's just the square root of the square of all of those 3 stresses, and that's kind of your von Mises. So you're getting all the stresses from all the directions, essentially. If I'm wrong, please correct me in the comments, but I just learned about this stuff in grad school, so just bear with me. What I like to do, so the deformed result, I thought you could change the, yeah, so true scale, you can see, you can only tell by the distance that it moved off the arrow. Yeah, so it moved, yeah, I don't comprehend millimeters very well, so I'm going to put this in inches, and then floating to get an actual number. So the max that it moved with me stepping on this is 0.03 inches. So you'd be fine. But that's not going to say that anything below this would snap or whatever. However you bolt this to your fixture, I guess. So just know that there's a lot of things that go into setup on an FEA. So don't just do an FEA and be like, oh my goodness, these numbers don't make sense, so the FEA is wrong. You probably set it up incorrectly, so it's very hard to do. The number one thing is does it make sense? If you can set up an FEA that makes sense, that if you have the opportunity to field test something, go ahead and field test. Make sure that the FEA data is making sure, or is bumping with what you're kind of seeing in real life. and it's a great way to estimate safety factors and kind of clean up a design before you spend a bunch of money making stuff. Um, so yeah, I hope this is helpful, and if you have any questions, let me know, and maybe we can learn something together. So thank you.